Hey guys, it's Rhett here. I've got an example for you today from the Unit 3 Physics course on uniform acceleration. So here we have a learner driver who's taken his dad's sedan and he wants to drive on the freeway. He starts with a velocity of 80 kilometers per hour and accelerates uniformly to 100 kilometers per hour in order to merge with the freeway. The total time for the car's acceleration was 4 seconds, and note that we also have the mass of the driver and the mass of the sedan. Calculate the following using appropriate number of significant figures. We want the acceleration of the car, the distance travelled, the driving force exerted by the engine, and then to describe some key assumptions. So hopefully you are aware in your course there are the 5 key equations of motion. Given 3 variables, I'm able to calculate a 4th using any one of these equations. The other key one to note here is converting kilometers an hour to meters per second, where we just divide by 3.6. Now I've drawn a quick little sketch here of the sedan entering the freeway. So note here that this is a bird's eye view. So here you have the car coming in, starts at 80 kilometers an hour, accelerates up faster and faster until it reaches the 100 kilometers an hour needed to safely merge with all the freeway traffic. Okay, so now that we've got a kind of picture in our minds, let's just start by writing out what we know. So we have the total mass, mt, of both the driver and the car is 1265 kilograms. I have the initial velocity, u, of the car, which is 80 kilometers per hour. Now I have to grab 80, divide that by the 3.6, 22.22. So there you go, 22.22 meters per second. The final velocity of the car was 100 kilometers per hour. 100 divided by 3.6 gives me 27.78 meters per second. And the other thing that I know is the time. So the total time was 4 seconds. T is equal to 4 seconds. Okay, so in order to work out acceleration, I have a look back at my key equations here. I've got V, U, and T, so I can use the first one, and I'm just going to rearrange it and then plug the numbers in. So the acceleration is equal to V minus U upon T, which is equal to 27.78 minus 22.22 divided by 4. Okay, 27.78 minus 22.22, 1.39. Now, the unit here, meters per second for acceleration, and I would consider for significant figures, I'll take that to 2. So that'll be 1.4 meters per second. Okay, the next part is calculate the distance travelled, B. So I advise my students here, just be careful when you're dealing with the constant acceleration formulae, you want to try not to use, if you can, try not to use what you've just calculated up here, just in case you've made a mistake in here. You don't want to bring that one through. So what I'm going to do, we want to know x, the distance travelled, and we know u, v, and t, so I'm actually going to use the second one here. You could in fact use the third equation involving acceleration, and I might just do that as a double check for the answer. So I get x is equal to u plus v over 2 times t. So that equals 22.22 plus 27.78 divided by 2 times 4 seconds. 22.22 plus 27.78, and then 4, and that's, so that'll be just times by 2. That is 100 meters. And again, if I wanted to take it to significant figures, 1 by 10 to the power of 2 meters. As a double check, so this is a bit extra. X is equal to ut plus 1/2 of at squared. U was 22.22 times the time of 4 plus 1/2 of a, 1.39. T squared is 16. And by the time you put all that into the calculator and work it out, you'll find that you also get 100 meters. So this is just a check. Okay, C, the driving force exerted by the engine. Now for this we need to use Newton's second law. So F net is equal to ma. Here we use the total mass of the driver and the car, which is 1265, multiplied by the acceleration that I just worked out previously. 1265 times 1.39, 1758. Now again, rounding this to two significant figures, it would be 1.8 by 10 to the 3 newtons. Okay, and then finally, what were the assumptions in our analysis? Okay, so we have assumed constant acceleration. We have ignored air resistance. Air resistance or any other drag, which practically speaking would come into effect at those high speeds. And we have also ignored friction between car and road. Okay, and that's the end of the question. As always, thanks for watching guys. Feel free to like and subscribe, and good luck with physics.